Now, just because this is a very famous name, though it is totally not required, also these are two different things, but I'll combine them, and instead of getting into the name details and other things, we'll directly try to see how we use these rules. First, we need to understand there is something called totient number or totient function, right? You can also call it Euler's number, right? Some people also read it as Euler's number. That's your choice. That doesn't matter actually. So Euler's number of a number. What is it? It is the number of co-prime numbers to n below n. That's the whole idea. So for example, what is totient function is usually represented as this phi. So phi of 60. What does it mean? It means numbers below 60, okay, which are co-prime to 60. This is what it means. We will need in this situation. So how do we calculate? There is a very direct method of calculation of this. Factorize 60. If you factorize 60, you get 2 to the power what? 2 into 3 to the power 1 into 5 to the power 1. Don't worry about the powers. Identify the prime factors. Prime factors are 2, 3, 5. So totient function of 60 or Euler's number of 60 is straight away equal to 60 into 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5. So standard process is phi of any number n is equal to n into 1 minus 1 by p1 into 1 minus 1 by p2 and so on, where p1, p2 are prime factors of n. Right? I hope it is very clear. Factors of n. You know, for example, in case of 60, if you simplify, you get 60 into 1 by 2 into 2 by 3 into 4 by 5. So 5 2s are 10, cancel. 3 cancel 6, 2 times 2 2s are 4, 4s are 16. So from 1 to 60, there are 16 numbers which have no common factor with 60. This is the totient function. If you understand that, you can also see that for any prime number, the totient function of a prime number is straight away p minus 1, right? All the numbers below p. Okay, that is actually Fermat's theorem, and Euler's theorem will be applicable for anything else. So don't worry about that, just understand the totient function. Now, how do I use it in questions? If I give you a situation like this, that let's say 3 to the power 79 divided by, let's say, 37. What is the remainder? So this is a weird situation, right? But you see this, just make sure that this base and this divisor are co-prime. Obviously that we have already discussed. Any rule will be applicable only in this situation. Okay. Now 3 and 37, they are co-prime to each other. Yes. Right. So instead of looking for the cycle in this situation, you can directly say that, you know, it will be, let's say the totient function of 37. Calculate this. Listen very carefully. Calculate totient function of 37. How much is it? It is a prime number. So it is simply 37 minus 1, that is 36. So the rule says that 3 to the power 36 divided by 37, remainder is equal to 1. This is the benefit or advantage. So in this case, what we can do is, we can convert the number 3 to the power 79 as 3 to the power 36 whole square. How much remains? 3 to the power 7 divided by 37. So for this part, the larger part, the remainder will be simply 1 square into. Now 3 to the power 7 you will have to divide carefully. Okay. What you can also do is 3 to the power 7 can be written as 3 to the power 4, that is 81, into 3 cube, that is 27. Divide by 37 1 by 1. So this will make it a little easier. So required remainder 81 divided by 37. 37 2s are 74. Right, so remainder is 7 into 27. Multiply carefully, it is 1, you know, we still need to divide. 27 into 7 is 189. Divide by 37. 3 5s are 15, 7 5s are 35, so 185. So answer would be 4. Just check it carefully. Right, this is the idea of this situation. We can also take one more case. Suppose we have 15 to the power 87 divide by, let's say, 28. Right? So 15 and 28, they are co-prime to each other. Right? Now find totient function of 28 first of all. I have not given you the theoretical statement of the theorem. I am directly explaining, right? So please pay attention to that. Simplifying totient function of 28. Now 28, we know it is 2 square into 7 to the power 1. So the prime factors are 2 and 7. So 28 into 1 minus 1 by 2 into 1 minus 1 by 7. How much is it? It is 28 into 1 by 2 into 6 by 7. Very good. 7 2s are 14, 2s are 28, 2 6s are 12. All right. So what do you see from here? Here we can see that 15 to the power 12 divided by 28, remainder is 1. That is Euler's theorem, right? As long as 15 and 28 are co-prime to each other, this will always work. This will always give you directly that power for which the remainder is 1. Okay, so how do we take benefit out of this? So 15 to the power 87 can be written as 15 to the power 12 to the power 87 7 times. 84, 15 cube will remain. Divide by 28. What you need to understand, that first part remainder is 1, right? 1 to the power 7, right? 15 to the power 12 divided by 28, remainder is 1. So 15 to the power 12 to the power 7, remainder is 1 to the power 7. But for 15 cube, there is no choice. The maximum that you can do is 15 square is 225 into 15 divided by 28. So this division has to be done in any case. Okay. So let's divide separately one by one. 28, 8 times is 224. Nice. So remainder will be equal to 1 into 1. 225 divided by 28, remainder is 1 into 15 divided by 28, remainder is 15 only. So the answer is 15. Right? So this is how we can use these theorems also. But in the exam, you don't get a question which cannot be solved without using Euler's theorem or Fermat's theorem. Just keep that thing in mind. It's very rare. It's just an alternate method, a good to know method. You might not be required to use it. Okay, focus on always on the primary method is always the cyclicity process, because questions in your exams are going to be much simpler than these complicated ones. They will be more logical. Okay, as far as CAT is concerned, they will always be a little more logical than the laborious questions.